So as you can see, we are reading that double-ended output of operational amplifier and how we can analyze its function, and we can see its fabrication. So what we can say is that if we apply two input signals such as V1 and V2, we get two output signals as shown in the book, that is V0 1, V output 1 and V output 2. So this can also be done by applying an input signal to either of the ends. So if I will ground this one, this non-inverting one, and if I will just connect an AC signal or a DC signal to the inverting terminal, so we are expected to get an output here. So this output is if we will see, this is the difference of these two outputs. So this will be V01 minus V02. So this will be the difference. So this will, we are getting the differential output. So let me call this as VDO. So you might have studied the superposition principle or constructive interference or destructive interference of the waves. So when we add two waves, like if we have two waves here, let me just clear this out. Okay. So if we have two waves here, we have wave 1 and we have wave 2. So when we add these two waves, suppose we add these two waves, and we call this as crest C and this is trough T. So when the crest and trough are in the same configuration or in the same direction above the your reference line, so when you add these two, you get an amplified output. So this is the constructive interference, so we will get the amplified output. Okay, so this will be twice as large as this one. Okay, so if I am applying this, we know that this when we apply a signal, suppose here we apply V1, so this signal gets amplified and it is in the same phase as this one, this input signal. So this is our input, so IP. Okay, so and this is our output, so this is let me call it as output. So this output is quite amplified, right? So this is amplified and also it is in phase, because this is a non-inverting end. So when we apply the signal to the non-inverting end, we get an amplified output which is in phase with the input, so we see this just matches with this, but this is an amplified version of that. And here, since I have told you that in this type of operation, in single-ended input with double-ended output, whether we apply a signal here or here, we are expected to get output at both the ends. So in this case, similar thing will happen, but the direction will get reversed, or this will be in out of phase with the input signal that we have provided at this end. So this is the inverting end. So this becomes inverting. So this becomes out of phase with the input. How much by out of phase? So this is 180-degree out of phase with the input. So what we are doing is that if we'll add these two, we'll get nothing. We'll get 5. So this is a destructive interference case. But we're not adding this one, we are subtracting. And like I have told you earlier, we are subtracting here, so we're getting the differential output here. So we're getting differential output, that is V01 minus V02. So if you will subtract these two, we are expected to get an amplified output like this. So this is the case that is happening here.